Alrighty, ladies and gentlemen, it is time for everybody's favorite shape, the circle. Yes, we are going to dive deep into the realm of circles and all sorts of fun properties associated with them here over these next few days. Let's start with maybe a little bit of a review for some of you. Some of you, you may not remember any of this. Who knows? We're going to find out. Alrighty, so we've got all sorts of different parts of circles and formulas associated with circles. Let's start with our radius. I'm going to label some points here just to help us identify things. We'll put an A over here. We'll call this guy B and this guy C. So we'd refer to this as circle B. All right, that's how you would notate that in geometry. You use the center of the circle as the notation for naming it. All right. Now our radius, that'd be like AB. Or you could have written BC. All right, that is the line segment drawn from the center of the circle to the edge of the circle. So I could draw that from the center all the way to here. That's another radius. And this is another radius. And this is another radius. Okay? I can draw an infinite amount of radii in the circle. Cool? Alrighty. I'm going to get rid of those so they're out of the way. Diameter. In this case, the one labeled right now is AC. It's just a line that is drawn through the center from essentially side to side of the circle, right? From edge to edge. So I could draw, boom. That's another diameter right there. It went through the center, and it went from edge to edge of that circle. All right? It spans the entire circle and goes through the center. A chord. All right, a chord. That might be a new one for many of you. A chord is just a line segment that's drawn on the edge of the circle to another edge and doesn't necessarily have to pass through the center. So we'll call this DE. So DE would be a chord in this case. And if you're wondering, well, could a diameter be considered a chord? Yes, it would be. It's just a very specific one because it goes through the center. All right, a chord does not have to go through the center. Alrighty, a tangent. A tangent means that it just... I totally missed it. Alright, it just touches the edge of the circle. So if it touches at one point, we'll call this point F. That would be a tangent line. Okay? I'm going to give this thing some other points. We'll call G and H. We'll pop some arrows on it. So GH... GH, you can label it as a segment or as a tangent, as a segment or as a line, I don't care. We'll just go with a segment since all of them are. But that is tangent to the circle. It's resting at one point, one and only one point right there. It just touches it. All right. A secant is basically a chord, but it's drawn through. So this would be like a secant line right here. Okay. I can call this I. I can call this J. Woo! Oops, that's the area spot. Hold up. Jumping ahead. I, J. We'll actually give that a line notation. I'll do that up here as well. Okay. Secant just means that it passes through two spots. A tangent, only one. Only resting at one. Alright. Time for some formulas. Area. If you don't remember that, write it down. Pi r squared. Circumference. Either 2 pi r or pi times your diameter. Why do those both work? Well, my diameter is just double my radius. My radius is half the length of the diameter. So I've got two formulas for circumference. All right? Now, those 5 new terms up top here, these 5 right here, that was a terrible little bracket. That's a little better. Those 5 right there, I'm not going to say like identify a secant line, identify a chord. I will be using those in the problem. So you have to know what those terms mean in order to understand what the heck the problem's even asking. So if you come to me 5 days after this first video and you say, Mr. Allen, I don't know, what is a chord? You probably didn't pay attention just now. Okay? So you do need to be able to identify those things in the context of a problem. Alrighty, some more terms as well as formulas to get to. So central angle. What the heck is a central angle? Well, it just means that it's an angle. We'll call this circle G. That is, its vertex is at the center of the circle. Okay, so call that G. I'm going to call these 2 points A and B. So central angle could be like angle G here. Okay, or why don't I use 3 letters? A, AGB, just in case we get a little more complex in this drawing. I don't know how many I'll add. All right. So central angle, AGB. Cool. Now, what that's intersecting right now, or what that's, intercepting right now, we say intercept when it comes to an arc. This right here, AB, actually I'm going to outline it like this in a different color. Let's go with purple. That right there is a minor arc, notated as AB, and rather than a segment, it's just an arc like that. Okay, so that's notating that I'm talking about that arc, which is on the edge of that circle. Now, what do the central angle and the minor arc have in common? The measure of the central angle, actually, I'm going to go ahead and type that in for you. The measure of the central angle is equal to the intercepted arc measure, and vice versa. Okay, so if I knew what the intercepted arc measure was, then I know the central angle measure. So for example, if I knew that the arc was, say, 70 degrees, then my angle would be 70 degrees. If I knew the angle was 70 degrees, then I know the arc is 70 degrees. Okay? Awesome. So that is what we're looking at for central angle as well as minor arc. Now, there's an additional one that I want to talk about. An inscribed angle. What the heck does that mean? Well, if I were, and I'm going to use the same arc, if I were to have this guy go all the way to here, and then I'm going to also go from B over to here, and let's call this point C. Angle ACB is an inscribed angle. Okay, well, what does that mean? The measure of an inscribed angle is half the measure of the intercepted arc. That's what an inscribed angle will tell us, right? That's where it is on C, that's what it looks like, where it's located, right? But what we actually get out of it is, well, if that arc is 70, as we already have, then this is going to be 35 degrees. Okay. Now, if I knew that the inscribed angle was 35 degrees, I can also then tell you that the arc is 70 because I can just double it. And these are some formulas that you'll want to write down. I'll put them all on one page here as well once we've caught up with everything. All right. Now, the only thing we haven't dealt with yet is our major arc. Okay, well, a major arc is bigger than 180 degrees. And a minor arc is less than 180. So this one is less than 180, okay, and then a major arc, that would be like arc, let's see here, it'd be like this guy right here, all the way around. Okay, that would be ACB, and that is larger than 180. So more than half the circle. Okay. Remember, there are 360 degrees in a circle. Jot that down if you didn't remember that. That's a good one there. 360 degrees in a circle. Okay. Cool, cool, cool. Woo! One more piece of information for you. Quadrilaterals that are inscribed in a circle. What do we know about quadrilaterals being inscribed in a circle? Well, first off, what the heck does it mean to be inscribed in a circle? To be inscribed means that, say I've got, well, how many vertices does a quadrilateral have? Quadrilateral is going to have 4 vertices because it's got 4 sides. So if I were to take a quadrilateral and I were to inscribe it in a circle, meaning each one of my vertices rests on the edge of the circle, just like that, if I did a better job with it, right? Assume that they're just on there. Thank you. All right. What do I know? Well, let's see here. This is A, B, C, and D. Well, my opposite angles of an inscribed quadrilateral are supplementary. So A is sup to angle C, angle B is sup to angle D. My opposite angles are supplementary. Cool beans. So I could ask you a question. I could say, hey, if angle A is, let's say angle A is 85 degrees. What's angle C going to be? Well, 180 minus 85, it's going to give me 95. So I can figure that out. Cool. Awesome. Wonderful. All right, first problem here. Solve for the measure of angle C if the measure of the arc AB equals 105 degrees. Well, if the arc is 105, that means we got 105 for this guy right here, right? And that is going from A all the way to B. Alrighty. So that's 105 degrees. What do I know about C? Well, C is my central angle. As you can see, we got the dot there that represents the center of the circle. You may even see on a problem like we have circle C. Okay? Circle, there we go, C. Okay, well, what would that mean for my central angle then? Well, my central angle is equal to my intercepted arc, so it is 105 degrees. Dunzo! Alright, this one says, in circle D, the measure of angle C is 42 degrees, so I'll go ahead and jot that down. Find the measure of arc AB, so I'm looking for this arc right here. Well, I know I've got some formulas, remember, right? So my central angle equals the arc. My inscribed is equal to the arc divided by 2. Okay, so these are two important formulas that I have so far, and we will add to those in the coming days. All right, an inscribed angle, or meaning like an angle that's on the circle is what they call it when it's inscribed. That means it's sitting, the vertex is sitting on the circle there. So it's half the arc. Well, I got to basically undo that. So right now what I have is the inscribed angle is 42, and that is equal to my arc over 2. So how would I solve for my arc? Well, I can multiply by 2 on both sides, and I'm going to get 84 degrees for my arc. Awesome. And we know it's a minor arc because it's only labeled with 2 letters, arc AB, right? It would need 3 if it was a major arc, meaning it's bigger than 180. Okay? So, follow-up question. What is the measure of arc ACB? That's my major arc. Arc ACB is this guy. Whoa, I came up with that one. Hold up. Here we go. That's a little better. Alright, so what's the measure of that arc? How would I figure that out? Well, how many degrees are there in a circle? 360, right? So if I take 360 and I were to subtract 84, well, what would that give me? 276, if I'm not mistaken. Yes, I believe so. 276 degrees. Boom. Alrighty. So I can ask you lots of different questions. I could give you one little piece and have you kind of work your way around the circle with facts that you know. You know that an inscribed angle is half the intercepted arc. You know the central angle is equal to the arc. You know that there's 360 degrees in a circle. So if you find out one portion of the circle, you can find out another portion potentially. Alright, so lots of different kinds of questions we can ask you with these. Alright, this next problem here. If AB is a diameter of circle D, find the measure of angle C. So we're looking to figure out what this angle is right here, right? Now, I think some of you might be looking at it and be like, it appears to be a right angle, but let's see, or we can't just always assume. It's always good to get a visual idea of what it might be, so if you get something that's totally not making sense, you can, go double check yourself before you wreck yourself. But right now, we're thinking maybe it's that. Let's see. Well, if AB is a diameter, what does that mean? That means that it cuts the circle in half. So if it cuts the circle in half, what is half a circle? Meaning, how many degrees is half a circle? That'd be 180 degrees, right? So for that arc, it's 180 degrees. Okay. Well, if my angle intercepts a 180 degree arc, and that angle is an inscribed angle, meaning it's on that circle, what's my formula for that? Remember, an inscribed angle is equal to the arc that it intercepts divided by 2. Okay. So what do I need to do? My arc is 180, isn't it? Well, what is 180 divided by 2. That is indeed 90. Therefore, my inscribed angle is 90 degrees. That is angle C. Awesome. Okay. In other words, what kind of shape do we have here for ABC? That's a triangle. If a triangle is inscribed in a semicircle is just half a circle, then it's a right triangle. Just a fun little fact there about fun geometry, circle type things, you know? Always good to know that kind of stuff. Awesome. One more problem. All right, so circle O has quadrilateral W, X, Y, Z inscribed in it, meaning all four vertices are touching the edge of the circle. If, this is all, there's the question, okay. If the measure of angle X is 115, so why don't I label that? Find the measure of angle Z. Well, what do I know about a quadrilateral with, or when a quadrilateral is inscribed in a circle? If you do remember the formula, it's nice and easy. If not, you're going to have a little bit more of a tough time. Okay? So, let's go with the stance of we remember, right? Opposite angles are supplementary in this case, okay? If a quadrilateral is inscribed in a circle, the opposite angles are supplementary, so 180 minus 115 is equal to 65 degrees. Okay. Now, if you didn't remember, is there a way to figure it out? That's a great question. Here's what I'm going to do. Ready? Well, if this guy, the 115 angle, intercepts at WY, what do I know about this arc? Well, it's double that. So that would be 230. That's another formula you'd have to remember. So what's left over for this arc out of the 360? Well, that would be 130, because 360 minus 230 is equal to 130. And then, since Z is an on angle with the intercepted arc of 130, right over here, what do I know about Z? Well, it's half that, 130 divided by 2 equals 65. So I can still get there. It's just a bit more of a pain in the butt if I don't remember that very easy formula, or the little fact about a quadrilateral being inscribed in a circle. So, although it takes a little more to remember all that stuff, it can make things a little bit easier, a little bit quicker, but it doesn't mean that you're totally, out of luck if you don't remember. You can think your way through it with some other basic facts of circles. Okay, good stuff. America, freedom, rock and roll, and Costco members only flannels.